In this problem, we have the following graph, and we are going to use the step functions to write the expression for our waveform. The step function is given to us as f of t, and this is going to be equal to the slope, so mx plus b, and then we have our bracket right here, and then we are going to have u t minus a, and then if we have another u, we're going to have minus u t minus a, and then we can close this up here, and this is similar to what we have down here. The problem is asking us to plug in our a values. Well, our a values are going to be the ones given to us. So we can see that we are given 0 and 2, and this is between our t. So our t's minimum is going to be over here, and our t's max is going to be over here. That means that our values are going to be the 0 and the 2. So over here we have that our a1, or our first a, is equal to 0, and that our a2 is equal to 2. And then we just plug them into the formula here, and then we get this answer. For this problem, we are given the slope right here. However, if we weren't given the slope, it's not too hard to find. What we would do, since this is a sine function, is graph a normal sine. So the graph of a normal sine is going to look something like this, and it's going to oscillate like this. And the max point is going to be 1, and the minimum point is going to be a -1. And the equation will look something like this: sine times x, or we'll have t in here because our x is equal to t. Now, if we want this max value to be greater than 1, all we have to do is multiply our sine by that value. So this is going to become 10 times our sine of t. Now, there is another issue that is here. And that issue is that I drew a cosine function, not a sine function. So an actual sine function will look more like this, but that doesn't really change our answer too much. It's the same kind of thing. And the difference here, though, is that we need something to multiply into our t here. Because if we have here as 0.5, and then we have here as 1, and then etc., well, if we just multiply 1 into this t, we're going to get a totally not 0 for our x-axis answer. And we want 0 for this point right here. If we just plug 1 for this t in, and we have 10 times sine of t, we're going to get approximately 0.17. And although that's close to 0, that's not 0. So what we can do is think about what can make sine 0. Well, one thing that can make sine 0 is 0, but we are away from 0, so we cannot use that. What we can use is a pi. So we're just going to plug our pi inside of here. So we are going to have 10 times the sine of our pi times t. And that is going to be the slope, and we can see that it's equivalent to the one that they gave us. So that's how you'd find the slope if we were not given it, and that is how you would go about solving for this problem.